All right, guys. So the Starship program seems to be going pretty well. It looks like we're going to be landing people on Mars in possibly 5 to 10 years. But the kind of sad thing is that those astronauts that go there are never coming home anytime soon. They're unfortunately going to be dying on Mars. So today I'm going to be taking you through what it's going to take to actually bring people back from Mars, and then if it's possible and if it's a good idea. So let's get straight into it. So if you listen to Elon Musk talk about this kind of stuff, he says one of the reasons they used methane for their fuel is because they wanted to be able to make it on Mars, right? So they could send home the astronauts. So basically, how this works is a Sabatier reaction, and you basically just combine carbon dioxide and hydrogen at a high temperature, and it just gives you methane and water, which you can make oxygen with. Okay, now people have already done this on Earth, kind of at a large scale. They have this big plant that they made in North Dakota, and then also recently, this company Pioneer Astronautics, they made this like a small scale demonstrator. So over 5 days, they made 5 kilograms worth of propellant with this little device. And so I'm going to be just using these specs that they give here, and then I'm going to be showing how it works at a big scale. Okay, so our methane machine here, it's going to make 1 kilogram of propellant per day. And according to that study, it used 17 kilowatt hours per day, okay, weighing 50 kilograms. All right, now we're going to, is traveling back from Mars possible? So this is called a delta V chart. It shows you how much acceleration you need to go different places in the universe. Basically, if you want to come back from Mars to Earth, you're going to need about 6,300 meters per second. Now, comparing that to normally on Earth, just to get into space, you need them around 9,400 meters per second. Now, the only problem with this is that you don't have the booster on Mars because only the ship can make it there, right? So you're basically going to need to just use the ship. You're barely going to be able to do it, and so you're going to need to use. You're basically going to need to fill up the entire Starship with 1,500 tons of propellant. All right, so here you go, a little chart here. We got 6,300 meters per second needed. You can make the payload a little smaller so that you have a little bit of margin, but basically you don't have a booster. You're going to need to use the whole ship filled up to the brim. Okay, now when you do the math on that methane machine that we were talking about, you're basically going to need 4,110 of these machines. Okay. So that's going to come out to 205 tons. So basically, you're going to need to send about 2 Starships to get this machine up and running, at least. But really, that's not the biggest problem. The biggest problem is going to be the power. Okay, so 4,000 of these machines over an entire year, let's say, that we're going to be making this methane, it's going to come out to 25 gigawatt hours, which is pretty much a shitload. Okay, now assuming we're going to be making this with solar. Mars is actually further away from Earth, so you get around about a half of what you get on Earth, but you still get about 600 watts per meter. Okay, that's about half. Now, I went on Amazon, 100-watt solar panel, weighs around 15 pounds. We'll call it 7 kilograms. All right, pretty cheap too. Well, not really, because you need 114,000. Okay, so if you do the math here, to make 25 gigawatt hours in a year, you're going to need 114,000 of these panels. All right, it's going to come out 800 tons just of solar panels. So you're looking at 8 Starships filled with solar panels, in addition to all the other crap you need. All right. Now, another issue before we move on is that when you're actually burning the methane, you're going to need double the oxygen of the methane that you produce. Okay. So when you work out how much water you need to harvest on Mars, it works out to about 5/6 of the mass of the propellant. Okay. Now, how are we going to get this? So luckily, the North Pole has a water ice cap, so you can basically, as long as you bring some heavy machinery, you can basically just scoop up the ice and dump it in a dump truck, and then drive it back to your little base. So yeah, this is pretty doable with one truck actually. If you could carry 7 tons, you just do 1 run per day, and there you go. It's around 1,200 tons, which is all you need. I mean, obviously the problem is there's no roads, and it's gonna be pretty treacherous living in on the North Pole of Mars, right? So, um, living on the North Pole of Earth is already really hard, and now you got to do it on Mars. So, anyway, that's pretty tough. By the way, there's a 1 meter apparently of dry ice that snows in the North Pole every year. So it's gonna be really hard to survive up there. You kind of be better off just making a base of the equator. Okay, now as far as the extra oxygen that you're gonna need something like this electrolysis machine that I found online. So this says it could do 1,000 liters per hour of hydrogen, and then it can make 500 liters of oxygen. So there's your extra oxygen right there. That would be plenty just with this one machine. The problem is you're looking at 5 kilowatts, so you're probably gonna need to double or triple that solar farm that we talked about. So now we're talking like 20 to 30 starships to get people back. Okay, so basically it's possible to get people back with Starship, but the problem is you're gonna need to send about 30 starships. So that's gonna be long after the first expedition, unless we want to send 50, 100 uncrewed starships with robots. Those people aren't coming home anytime soon. So I think it'll just be part of the program where astronauts just expect to live at the Mars base for the rest of their life, and it'll be kind of a tough thing. It'll be like when people first came to America on boats, except they'll never be able to go home this time. So anyway, let me know in the comments if you think this is a good idea, if you think going to Mars is a good idea in the first place, and let me know if you would go to Mars. All right, have a good one.